Hello, today we're going to be talking about dividing polynomials. We are going to be looking at how to divide polynomials using both long and synthetic division. And then we are also going to look at the remainder theorem and the factor theorem and how those can be helpful to us. So let's get started with this example. We're going to do this first one using long division. So I'm going to set up my division problem just like we do in arithmetic. We're going to write the dividend underneath. And then we're going to put the divisor outside. And then we're going to try to find our quotient. So in normal division, we decide, okay, what do I need to multiply by to get from this x to the x cubed? And then that value goes up here on top. And then we multiply and we subtract. So we're going to go through that same process. So what do I need to multiply x by to get x cubed? Well, the answer to that is x squared. So then I'm going to take this x squared and I'm going to multiply it by the entire divisor. So that'll get me x cubed plus 2x squared. Okay, now once we've done the multiplication, then we're going to subtract. So that means I'm going to change the signs on both of these, and we're going to do the subtraction. So x cubed minus x cubed is 0, and that is what we want to happen every time in this first column. Okay, now we go to this next column. I do make sure my exponents are lining up so that this is like terms. 2x squared minus 2x squared is also 0x squared. And then I bring down my next piece. Okay, and now I go back and I decide what I need to multiply by. So now what do I need to multiply x by to get not 0x squared? That would be a 0, right? But I need to go to this next piece. So I would need to multiply by a negative 3. And then I'm going to take that 3 and I'm going to multiply it into that divisor. And we will get negative 3x minus 6. So I need to bring this next piece down. And now I need to do my subtraction. So that means I'm going to change the signs. And I end up with 0 plus 7, okay? Now, I don't have anything else to bring down. There's nothing else over here. So that means I'm done with the problem, and this is my remainder. Now, if you remember when you learn division, when at the very, very beginning of time, you always just put R whatever. The next phase of learning division was to learn how to write that remainder as a fraction. And so our remainder here is going to be 7 over the divisor. And then we add that remainder. So my end result is x squared minus 3 plus 7 over x minus 2. Now, if you wanted to check your work, the check would work by taking the x plus 2 and multiplying by the result that we got. And when I do that multiplication, I should get back to this original dividend. So when I do this, we're going to multiply this out, and that gets me x cubed minus 3x. I can multiply the 2 through, and that'll get me 2x squared minus 6. And then I'm going to take this whole thing and multiply it by this last piece. So that'll get me plus 7 times x plus 2 over, excuse me, it's x minus 2, isn't it? No, it's a plus. Okay, then this cancels, and I'm left with x cubed plus 2x squared minus 3x, and negative 6 plus 7 is a 1, and I end up with what I started with. So this is my answer, and it checks. Okay? All right, let's do another one. So long division. Again, I'm going to set it up. Now, I notice in this polynomial in the numerator that there is no x cubed term. So I want to make sure I put that in as a placeholder. It's just like if I was dividing into 1001, I couldn't write 101 and leave that 0 out, or even 11 and leave both zeros out, because they're not the same number, right? So I have to put those 0 placeholders in there. Okay? All right, so let's start. What do I need to multiply 2x by to get 4x to the fourth? Well, 2 times 2 would be 4, and then I'll have to have an x cubed. So now we multiply, and I'll get 4x to the fourth minus 2x cubed. And then we do our subtraction. So I'm going to change these signs, and I end up with 2x cubed. And then I bring down my next piece. And I do the process again. So now I need to, it's got 2 and 2, so I'm just going to multiply by 1. And to get to the x cubed, I need to multiply by x squared. So now I multiply this through, and I get 2x cubed minus x squared. And then again, we're going to do our subtraction. So I get a 0, and then I get 4x squared, and I bring down my next piece. And then I do the multiplication again. So now I need a 2x, and I multiply it through here. So that'll give me 4x squared minus 2x. And then we're going to subtract. So I change my signs, and that will give me 0. This will also give me a 0, and then I bring down my last piece. Now this last piece has no x's, and my divisor has an x. So this is my remainder. Once I get down to that constant piece, and so I'm going to add my remainder, and I'll put 4 over 2x minus 1. And this is so my answer to the division problem is this quotient that I got. Okay? All right. Now, let's talk about synthetic division. Synthetic division only applies when the divisor is a linear, in particular, x minus c. Okay? So this divisor is in that form, and my c value is 3. Okay, see, x minus, minus, okay? So what I'm going to do is I'm going to put that 3 in a little box. And then I'm going to take what I was dividing into, and I'm going to write all the coefficients. So this is my x to the 5th. I have no x to the 4ths. X cubed is -3. The x squared has 2 of them. There are no x's, and then my constant is -4. So it is imperative that you put the 0 placeholders when you're doing synthetic division. When you're doing long division, sometimes you'll realize as you're going through the multiplication and subtraction that you're missing them. But in synthetic, you won't. You have to put those zeros there. Then what we're going to do is we're going to go through this multiplication and subtraction process. Now, interestingly, because I put c here and it is the opposite, see this was a -3, then all the subtraction has been taken, the changing of signs has been taken care of, and now I'll just be able to add down. So we're going to bring down the 2, and then we multiply, and I write my result right here. And then we add, and we multiply. So 3 times 6 is 18. And then we add, and then 3 times 15 is 45. And then we add those, and we multiply. So 3 times 47 is 141. Let's just, okay, so that's 141. Then I add, and then 3 times 141 is going to give me 423, and then I add. Okay? Now, doing the division, this was an x to the 5th, so this first one is going to be x to the 4th. The x to the 4th spot is now x cubed, and then x squared, and then x, and then this is my constant, and this is my remainder. And so this is my result. So this ending spot, the last one, is always your remainder. Okay, so synthetic division can go a lot faster, and it's less likely to have errors in it as long as we make sure we write down those coefficients, including the 0 placeholders, correctly. Okay? All right, now, one of the places this can become helpful is in using the remainder theorem. The remainder theorem says if some polynomial, okay, is divided by x minus c, then the remainder will equal the value of f of c. So in order to find f of 3, I could take and plug the 3 in. But if I don't have my calculator, sometimes, or if it's a negative number or maybe a fraction, or the numbers get really large, sometimes this is not quick. So I can also choose to use the method by putting the 3 in my box, putting my coefficients here, and then I can simply do multiplication and addition. Multiply, 3 times 5 is 15, and add. 3 times 12 is 36, and I add. This right here is my remainder, so f of 3 would equal 40. Now let's check. So over here, when I just plug in the 3, I'm going to get 27 plus 2 times 9 minus 9 plus 4. So that's 27 plus 18 minus 9 plus 4. So that ends up getting me 40. Okay? So sometimes it's quicker just to do the division in order to find that function value. Now, an extension of the remainder theorem is what is called the factor theorem. So if f of c is the remainder of f divided by x minus c, then f of c equals 0 means x minus c is a factor. Because basically, if f of c equals 0, this means the remainder equals 0. Okay, so all I have to do is take this. This would be x minus a negative 1. So I'm going to put a negative 1 in the box. I'm going to write my coefficients down, and I'm going to do the division. So I bring down the 1, and I multiply, and I add. I do the multiplication, and I add. And I do the multiplication, and I add. This remainder equals f of negative 1. So if it equals 0, that means that x plus 1 is a factor. Okay, so that means that this polynomial is divisible by x plus 1 with no remainder. That means x equals negative 1 is a root or a 0, and x plus 1 would be a factor. Okay. All right, now this is helpful in problems like this. I cannot factor this cubic polynomial very easily. It doesn't even factor by grouping because I have nothing in common between the 7 and the 4. So what I can do is divide this -1 out and see what we get. So if I take and I put the -1 in the box and I write down my coefficients and I do the division, okay, then what I'm left with is x squared minus 3x minus 4. So this means that f of x is equal to x squared minus 3x minus 4 times x plus 1. Okay, because this tells me that x equals -1 is a 0 or a root, which tells me x plus 1 is a factor. So when I do the division, this is what I get. So now I can factor this quadratic. Okay. And so now if I want this to equal 0, because that's what it's asking me for, I know that x would equal 4. And both of these would give me x equals -1 with a multiplicity of 2. So I can use the synthetic division to help me factor, okay, which will help me solve and find the roots. Okay, all right, so hopefully that gives you a little bit of a picture of how to do division of polynomials. If you're in class with me, I will see you in class and we'll do some practice on this. If not, if you've got some questions, feel free to comment down below and feel free to subscribe, and we'll see you next time.